Good, thank you. Hello everyone, thank you for coming to my talk. I'm Alex, and today I'm going to be talking about geographically distributed Kubernetes clusters. So a little bit about me first. I do fun things with Kubernetes. I run a home lab in Iraq in the living room at my place. Currently I work at a company back home called La Sentinelle, in Mauritius, by the way, where basically I'm the Kubernetes person. If you want to contact me, there's some socials and my GitHub over here. So myself, I'm interested in Kubernetes, Linux, and generally free and open source software. And as I mentioned, with my home lab, I have a tendency to play with Kubernetes a lot, which is sort of the base actually for this talk today. So I wanted to start off with a bit of the state of the cloud in Mauritius. And nowadays, we're talking about cloud native with Kubernetes, with distributed high availability architecture. In Mauritius, we're not doing cloud native, or not really. It's very cloud naive. Because until recently, the government's official position was that the cloud is bad. It's evil, don't put your data there, don't even start to use it. And this is a bit of a funny stance for the local government to have taken, especially because they like to position Mauritius as we are the fintech hub of Africa, we are digital pioneers in the Indian Ocean, and a lot of that kind of stuff. Nowadays that cloud's been adopted a little bit, people are starting to be familiar with AWS and Azure, GCP and the like. Most people or companies, they still view the cloud only as someone else's computer or just servers in the cloud. They don't have to maintain it. They don't have to pay electricity bills or manage the networking and stuff like that. So, as I said, we're from Mauritius. Well, I'm from Mauritius, and this project, which I'm talking about, is mainly Mauritius-based. So, I wanted to show how connected Mauritius is. This is a map of the undersea internet lines which connect the world, basically. Mauritius is all the way down there. And because that's a little speck of dust in the Indian Ocean, here, zoomed in a little bit. So that's us. We've got some maybe two or three, I think it's three undersea cables which literally connect us to the rest of the world. And it's a problem when you've only got 2 or 3 lines, because if you have damage to one of those lines, and I'll just go back here quickly, the thickness of the line represents the data capacity. So at the end of the day, we've only got one really high capacity line leaving Mauritius. So if there's any kind of damage to these 3 lines, or maybe even lines further up the chain, we have severe internet outages, which really disrupt, local infrastructure and well, literally our connection to the rest of the world. So this is what a case of no internet looks like to us. Cable damage causes, and this was from the last time we had issues, where I think 2 of our 3 cables were severely damaged. We had some 600 milliseconds latency to Europe, 1.5 whole seconds of latency to North America. And because we've got this kind of awful connection now, all sorts of applications and websites are going to time out. Banking applications are going to fail, ATMs and all sorts of, critical infrastructure like that, including insurance applications, they're all going to be down, inaccessible, or generally just hard to use. And the worst bit of all is Netflix is inaccessible. So while you can't do your work because you don't have internet, you can't even not do no work because you don't have Netflix. So also we have the state of cloud service providers in Mauritius. There is one, cloud.mu, which is the only, I believe, only cloud service provider in Mauritius. Of course, we've got the big players, AWS, GCP, and Azure. But they're not going to set up data centers wherever we want, basically. They've got strict requirements for setting up data centers, including network redundancy, which we don't have, power redundancy, we have only one electricity grid, and there needs to be a minimum distance between data centers so that if you have a natural disaster of some sort, a tsunami or whatever, that your data centers, both of them aren't going to be taken out at once. So this means that the closest of these 3 cloud service providers is in South Africa, some 60 milliseconds away, but most importantly, it's an undersea cable away. And of course, now if we're going to move to these cloud providers, and we're going to be trusting our local infrastructure on that one cable. So what does this mean for high uptime? So obviously running on-prem, I'm sure a lot of people prefer doing on-prem, but it requires significant investments, especially if you want your production environment, you're going to want your DR, you're going to want a backup, and now even backup, a lot of people like to back up to S3. But again, S3 is in South Africa, nowhere near us. It must be nice, I guess, for a lot of you coming from Europe who have literally data centers in your backyard, right? Whereas us, not as easy. If you want to run your infrastructure in a data center, in Mauritius itself, you don't have the same level of physical redundancy that proper cloud service providers give you. And I said my home lab would come into this a bit more, and running my home lab is, of course, victim to power cuts. In terms of high uptime, it's not great. The infrastructure we have, the connections we have to the outside world don't permit us to have the same level of high availability and redundancy which a lot of people in Europe or North America are able to benefit from. So this is my solution. The world is your home lab. I like running home labs, so why not make the world my playground, in a sense? And you're probably going, well, Alex, what on earth are you talking about? Well, hear me out. Hosting your services on-prem is nice. After all, I like my home lab. It runs my website. It runs my ForgeJo instance. It runs many things. But when you lose power or lose maybe internet connection, things like that, you're going to be losing all your running services. And that's going to ruin your very nice uptime stats. Companies have a tendency to use multi-cloud for better reliability, right? I mean, some companies might have a replica of the infrastructure on both Azure and GCP. So if something happens to one, maybe a data center catches fire, you're still able to have some failover to another cloud service provider. Given that Mauritius isn't big enough to have big data centers, big cloud service providers, I wanted to talk about multi-home labs. Many home labs across the island all connected together and coordinated through Kubernetes. So, me and a few friends, we came up with a great plan. We said, okay, we're going to have, let's say, 3 data centers, which for us, houses. And let's say we'll put 3 machines per house. Small computers, low power, maybe even those ultra small form factor PCs that a lot of companies get rid of. So that would give us a Kubernetes cluster of 9 nodes, which would be spread geographically across the island. If one of us is going to have a power cut or damage to our internet line or something, well, our services are going to just fail over to the nodes in someone else's house, and everything stays running. So we have a pretty interesting tech stack which supports this kind of national infrastructure. Actually, for context, Mauritius is, I think, only slightly bigger in terms of surface area as Nuremberg. So that puts it into perspective for a lot of people here. I'm not saying take this same idea and apply it to the entirety of Germany, because this is way too big. But for us, it's perfect. We've got K3S, which is a lightweight version of vanilla Kubernetes, K8S. It comes everything batteries included. It's obviously open source. And it makes setting up Kubernetes clusters easy, just one command. There are plenty of other Kubernetes distributions, I'd say, such as K0S, you've got Talos. You've got many choices if you want to try something like this. But we went with K3S. I'm used to K3S. So yeah. Longhorn is going to do storage for us. It provides persistent storage for the entire cluster. What's really cool about it is you can configure it, or by default actually, it creates replicas of your storage volumes across the different nodes in your cluster. So in my personal home lab, I've got 3 nodes, and I can say, hey, if I've got my image server, my images are important. I want to keep them there, so I can have 3 replicas. And every time I'm going to change or add something to a volume, that change is going to be literally replicated to volumes on all the other nodes of the cluster. So in the same way we are saying that we're going to have redundancy for our hardware, we also want redundancy and that sort of backup plan for our data as well. Not like my house goes down and then all of a sudden we lose the data which was at my house. We want replicas everywhere. Longhorn, compared to another option, Rook and Ceph, it's fairly lightweight and nonetheless very performant. To tie that together for a bit more of a robust backup solution, Longhorn, it can use S3 buckets or you can use NFS. So using Minio would allow us to have basically our self-hosted S3 instances in Mauritius and gives us and Minio also gives us the facility to have a distributed cluster for backups. For the moment, we don't have a cluster for our backups because we don't have that number of nodes and we don't care about our backups to that extent yet. And finally, we have Tailscale. Tailscale, it gives us a virtual mesh network for all the nodes across the entire island to communicate. Because for each of our houses, we are only on like the domestic ISP plan. So it's not like we have an IP we can assign to each of our nodes. So one public IP per house, we can't expose all those nodes, so we are going to use Tailscale to have that mesh for all the nodes to communicate. Now, something which is actually very interesting about the networking situation in Mauritius is a while ago, if you had network data going from one ISP to another, we didn't have an exchange point in Mauritius itself. So you'd have to go to South Africa and back, which gives you that extra hop of, hey, something can go wrong on that internet line. But since then, we've got the Mauritius Internet Exchange Point, which gives us much more robust networking within the island. And that's also important because for the networking within our island itself, it's great. When I pay for 200 Mbps download, I get my 200 Mbps download. But with the same plan, I have maybe, 60 Mbps download to South Africa. So that degradation is exponential relative to the distance of the target from Mauritius. So Europe, you're going to have much worse download speeds compared to that. And actually, it's that networking situation with the rest of the world has also caused a bit more interesting developments in terms of like local mirrors for Linux. I believe there's going to be a talk about that later. But yeah, so local networking, having everything pass through the network of Mauritius itself is a huge advantage in that sense. So despite that, we have a few issues. I mean, Kubernetes is made to be production grade. You put it in your data center with robust servers and everything. It's built for something serious. Our project here isn't, that serious as such. So some issues you might have is latency, because the default etcd heartbeat for Kubernetes has a timeout of only 100 milliseconds. And if you're going over long distances, then all of a sudden you're going to maybe have etcd timeout, or your control plane is going to go out of sync. You're going to have issues maybe even in data replication. We also have issues of power cuts. So given we have only one grid, it is, compared to Europe, where you rarely have power cuts, I believe, in Mauritius, it happens that power cuts are somewhat more regular in different regions of the country. So if you're going to have your control plane in one place, it does make the cluster vulnerable. But in that case, you could maybe put one control plane node in each house to have your redundancy. Another issue is, again, with the domestic ISP plan that we all have, it's that our routers are going to cycle their IPs every 24 hours. I guess this might be intended so you don't actually host any services at home, but maybe the ISPs haven't heard of the DNS and stuff like that. But once again, this issue is mitigated with Tailscale, because after all, the network the virtual network across all the nodes doesn't depend on us having port forwarding or any of those kinds of things of the ISP router. Also bandwidth, which I did mention a bit earlier. You would prefer to have good connection, especially when you're going to do your data replication, because you don't want to be pushing in so much data and then you can't actually replicate it across all your different nodes. So you don't want some replicas to go out of sync, which might throw off the integrity of the cluster. Again, bandwidth, thankfully, because everything stays within Mauritius, we've got pretty good download rates within the island, so that does actually help for replication. We haven't yet had any issues, that's what I mean to say. So we've got some future goals for this cluster, mainly community-focused. Because after all, if everyone, or well, me and my friends were basically owning or hosting those nodes in our houses, we'd like to have a Kubernetes cluster which is owned by people and make it available for people. So not exactly as much as cloud service providers where you gotta pay every time. Instead, hey, you could host a node and then you'll have access to the Kubernetes cluster. We're looking into running a K3K or vCluster, which would let us create, literally virtual clusters on top of that host Kubernetes cluster. So the idea is to provision clusters within that large one for people to use, play with, experiment, and learn about Kubernetes. So maybe to advance adoption of cloud-native technologies, Kubernetes, and things like that. Also because not everyone, and we understand, not everyone can have a home lab with so many use of rack storage in their house. So having something like that community-focused would let people experiment a lot more. Short term, we're looking to get a lot more people from Mauritius involved, replace some of the old nodes that we've got, and probably make it a little bit more performant so that more people would be able to use it. At the end of the day, I'm hoping that people would be able to regain maybe a level of digital sovereignty, host their own cloud, basically, and detach, from relying on external providers, even like Google Cloud or Google Photos, so we could have a lot more of our data within Mauritius. And it is nicer having more of our data kept to ourselves at the end of the day. So now this is more or less the end of my presentation. Here you can reach me, but I would be very happy to engage in some discussions with you, whether you have ideas for how we could build up on such a scaled cluster. Anyone comments, questions? Yes, thank you.
Given your tech stack includes Tailscale and you have some issues with regular network outages, how is off when you don't have a reliable connection out? Because I'm guessing Tailscale doesn't have a node in Mauritius.
Yes, you are right. Tailscale itself does not have a node, a server within Mauritius. However, fortunately, there is, I believe it's called Headscale, which is an alternative to the Tailscale server, which you could self-host, which does the node discovery and advertising for you. So you can still use Tailscale, but just use your Headscale instance as a server instead. We could probably put that on the cloud service provider, cloud.mu here. There are, I think, other alternatives built on top of WireGuard, which we might explore in the future.
Thank you, Alex. This is really great.
Thank you.
I was actually going to follow up on that in terms of the tech stack Headscale. Have you actually, is it actually in use? Are you actually taking advantage of that? And Headscale, for the control planes for Tailscale.
Headscale, we are not using it yet.
Okay.
It is something that we're planning to do actually very soon.
Okay.
We are looking to practically destroy the existing cluster and then rebuild it from scratch with better nodes, a bit better in general.
Okay.
So when we're going to do that, then we're going to see that it's going to be a bit more worth it, and then also having more people using the cluster to then have Headscale to give us a bit more of that robustness.
Okay. I think I'll talk to you later.
All right, sure. That I would very much enjoy that. Anyone else? All right. Well, thank you very much, everyone, for attending my talk. It's been nice. If you have any questions, I'm at the shop most of the time, so you can come and talk to me there. Thank you.